Okay, so remember these check-ins and closings will help you on the CTBA, which is on Thursday. These, we've seen this one before twice, I think, and once pretty recently. I don't know if it was last week or the week before Thanksgiving. We've seen it recently. Anyway, it describes what the graph is doing. You can tell that if this thing is falling down, not just because it looks like it's falling, but because this is position, so it starts at a high position, at a height, and then it falls down to 0. So that's how you can tell, since it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, that's it falling, because its height is decreasing. You can also tell that it's going slow, and then it's going fast, because over here in this last second, it goes 1, 2, 3, 4, 5 meters down. So 5 meters per second in that last second, since it went 5 meters in 1 second. This thing's asking, what is its velocity from 0 to 4 seconds? So it was between 1, 2, 3, 4 seconds. It goes down 2 meters in those 4 seconds. Remember, this is position, so we can't just look at this and say it went 10, 9, 8 meters. It's asking for velocity. Says what's its velocity? So we need meters per second, which means it went down 2 meters in 4 seconds. So to get meters per second, we do meters divided by seconds. So negative 2 meters divided by 4 seconds makes negative 1/2 meters per second. The reason this question has been repeated so much is because people like to miss the one that this goes over the concept for on the CTBA. So if you can analyze this graph, then you can answer that question right on the CTBA, the one that this is like. It's not exactly like. Anyway, so the thing today, this is our last day of practice before the review and the test. It'll have you do potential energy and kinetic energy and work and now power. We only did a couple of power calculations in the lab, so I'm going to show you a power one here. Work is part of it, so we might use force and distance here instead of work, because work is equal to force times distance, so this would be the same as saying work divided by time would be the same as saying force times distance divided by time, and that's what this one's going to do. But remember, if it gives you joules and asks for height, even if it says it's got so many joules of kinetic energy or so many joules of work, how high did it go? Plug those joules into PE and then solve for H. Or if it gives you like somebody did so many joules of work pushing a shopping cart, how fast did it go when they let it go? It's asking for how fast, so plug those joules into KE and solve for V. Don't forget your square, don't forget the square root at the end. This one. So this is a power one, and it gives you all sorts of things, and it's a little weird. So this person won a stuffed animal at a carnival. They extended it 0.5 meters out. 0.5 meters out, that's a distance. Meters. With a force of 30 Newton. That's the force. Okay? 30 Newton. Okay, celebration. They made it really dramatic by taking 5 seconds to extend it that distance. So time equals 5 seconds. 5 seconds. What was their power output? I don't know. Power equals blank. Are we done now? Yes, okay. Well, I guess we're going to have to use the power formula. It's asking for power. Y'all remember the unit for power from last week? Watt? What? Oh yes, watts. Yes, that's right. Yeah, so our answer is going to be in watts. Like I'll put a W right here. This is where it's confusing. You got to keep this straight. This capital W is the unit, is an abbreviation for the unit for watts, for power. This capital W is an abbreviation for the variable work. So just, you've got to remember that. There's no real trick to it, I guess. So all right. Let's see. We've got time. So I can put my time in for T, and we're looking for power. So I can just write P Did not give us W. This is where we have to split that W up because work equals force times distance. And I guess you can see it right there too. Work is force times distance. Instead of work divided by time, instead of work, I'm going to write force times distance. So I'm going to do force times distance divided by time. Then it'll be fine. So let's see. I'm looking for power. So I just need to plug in these three. Force is 30. Distance is 0.5. And time is 5. Okay. Did y'all get it already? What is it?
30.
30 times 0.5 is 15, right? What's 15 divided by 5?
3.
3, okay. And what's the unit now?
Watts.
What? Oh, I love to say that. Here we go. 3 watts, because we're doing power, and then we're done. But sometimes it might ask you, it might give you power and time and distance, and ask what's the force. And you'll be like, but the power formula doesn't have force in it. Well, yes, it does. You got to split it up and then solve for force. Seem all right? Make sure you all ask me questions. Make sure you all ask me questions. You got questions? Please go to this work, energy, power practice.